I now have all 6, and this is not hot. Always a good idea to check things to see if they're hot before picking them up in the hot shop. So I've got a rig here, and this is not hot. And what I want to do, let's turn off Mr. Bunsen. Get my piece going in the far flame. Now I'm going to preheat, and I probably could have put this in the kiln, but the kiln was all full of other stuff, and so all I need to do is just kind of preheat this a bit. Doesn't need to be super ripping hot, but I don't want to put hot glass on cold material. So this rig that I made has 12 threaded blocks around the outside, and the blocks are made of graphite. The frame is made of steel. The threaded blocks are made of graphite, and the screws are stainless screws. And I just realized that I need a tool, because I can't touch those screws once they get hot. I gotta go out and get a tool. So, yeah, that'll do. Thing has 12 threaded blocks with stainless screws, and then I've got a variety of other graphite blocks that I can put into position and then use the screws to kind of press things together. I've pre-sized this with the pieces when they're cold, so I should be just about ready. And the little stand here is designed so that I don't have the piece sitting right on my table, for 2 reasons. I don't want to overheat the tile and crack the tile, and second of all, having a little airspace in there. Air is an insulator, and it allows the little fixture to stay a little bit warmer and not lose quite as much of its heat, which is not that important in this operation. I could probably do it cold, but hey, I've had glass crack when I take it out of the kiln and put it on cold graphite, so just got to be careful. So it looks like my puller guy is just about getting ready. And I actually am able to, this is going to be a little tricky maybe, as I assemble these things together. Fortunately, the pattern is fairly easy to see. You know, These handles are just too long. This is only the second time that I've done this process, and I'm still working on optimizing things. I'm now screwing and no, they don't line up perfectly, but they do line up very, very nicely. And so the next step is going to be heating them a little bit. These little protuberant nubbins don't matter at all. The piece I'm picking up just needs to be hot enough to stick. And my moil needs to be ripping hot. Okay, here we go. And there it is. And it appears to be highly successful. And while that's heating, I'm going to add the additional squeezing dies to return to a hexagonal configuration, 1.25 inches on a side. That thing is way too hot to touch. Just cleaning up the bench a little while I gently get a little bit of heat into the assembly. My weld is pretty good. I'm reasonably confident that I've got a good weld, but it ain't that good. The whole thing is still a bit on the unstable side, so I'm concentrating my flame on the moil weld attachment area and looking over at the video system, making sure that all is well. And as I've said many times, one of the nice things about the NQALHA is being able to let things heat up slowly. There's a lot of sensitive colors in these pieces, and if I put it directly into the high flame and try to rush it, I'm going to get a lot of degradation on the surface. And by using the machine, especially, this is getting to be a pretty heavy piece. And by using the machine, I can just kind of like sit back, relax, take a look, and let it very slowly soak in some heat. And as I've said many times, glass is an insulator. Cold glass is an extreme insulator. As glass gets hotter, it starts conducting a little bit better, which makes it a kind of a non-linear behavior, which drives beginning glass workers crazy, because it's like you're heating. Is this thing ever going to get hot? I'm getting bored. I'm heating. Oops, too hot. And so I'm convinced that understanding heat, that's the keys to the kingdom. Once you understand heat, you're on your way. And no, I don't understand it yet, but I'm getting, every time I go out in the shop, I get a bit better. So I can see by looking at the end that the end is dead cold. Got a big hole in the middle that I'm going to have to fill by squeezing. Squeezing is great for filling holes, especially if the air has somewhere to go, has somewhere to escape. And even though the squeezer produces reasonably sharp corners, you can't get a perfect corner in glass unless you cold work it. Glass likes to round over. Just the nature of the material. So, moving a little bit closer to the torch face, being very aware of any signs of boiling, degradation, other bad stuff on the glass. Oh, this guy is getting heavy. Ooh-wee! Gives me even more respect for the glassworkers I know who work with really giant stuff. I call this big. Their stuff is really big. Okay, first squeeze. Very gentle. This is just a kind of a slight consolidation. Purpose of the first squeeze is just try to tag it together a little, stabilize it a little so it doesn't start flying apart. When I'm doing a stack of cold rods, there's a lot more danger of the rods starting to bow out before they're tagged. Assembling thick stuff like this is much safer. So, slow as it goes. Slow, slow, slow. Inside is still dead cold. Takes a long time for the heat to soak into the core. Every time I touch the outside with the squeezing dies, it freezes the outside, but it doesn't suck out the core heat. So by repeatedly using a small, gentle squeeze, I help drive the heat into the core without overheating the outer surface. Second squeeze will also be gentle. I can see already that it's more consolidated. I see fewer gaps. Everything is looking like it's getting reasonable. But even with a Delta Mag, it takes a long time to drive the heat into the core of something like this. A long time. And I know I've talked about this many times before, but while I'm watching it slowly heat, I'll say a couple of words about my oxygen system. This is a do-it-yourself oxygen system, and when I see comments on social media where glassworkers are saying, hey, I'm looking at an oxygen system, which one should I buy? And then I see somebody say, oh, build your own, it's easy. Well, it depends. It was easy for me because I'm an engineer with a machine shop with 40 years of designing control systems and computer-controlled equipment. It was easy for me. But for somebody who's never done it before and maybe doesn't have tools, doesn't know how to deal with simple things, buy a system. HVO is great. Oxygen Frog is great. I know both of the owners and good guys. Of course, no business is perfect. I've heard bad news about many companies where people have had problems, but anyway, building an oxygen system is easy if you have the experience and the tools. So My oxygen system is a hybrid system, a combination of low and high pressure storage. The low pressure system uses 3 oxygen concentrators, one 10-liter, 2 5-liter, for a total of 25 liters per minute. Second squeeze, getting a little more aggressive now. Kind of standing on it a bit. Noticing that, yes, I am closing up the interior. But everything, at this scale, everything happens slowly. So the low pressure system uses a oil-free California air compressor that can compress up to 175 psi, and it's going into a pair of tanks, a 20-gallon and an 80-gallon, for a total capacity of 100-gallon. And then I've got a home fill, or actually 2 home fills, connected to a 5-liter per minute oxygen concentrator. Home fills only take a little over, between 2 and 3, depending, that they pulsate. They only take about 2.5 to 3 liters per minute, so a single 5-liter per minute oxygen concentrator can easily support 2 home fills. So I've got the 2 home fills pumping 3 of the larger tanks, commonly referred to as K-tanks, pumping those up to 1,000. And the combination of that means I can run a Delta Mag, because when the low pressure system runs out of poop, the high pressure system automatically kicks in. Everything's automated. I designed my own controller, and with a combination of solenoid valves, a microcontroller, and check valves, the whole thing's completely automated. So, as glass gets bigger, the process gets slower, and I mean slower. It's very nonlinear. Everything about glass is nonlinear. Twice as big doesn't mean twice as hard. Probably some sort of square law, maybe a cube law. Maybe twice as big is 8 times as hard. Something like that. Hard to quantify, except this is not easy. And of course, like I said before, the guys I know who do truly gigantic work would be watching me and going, dude, that's not even close to big. But if all you've done is little stuff, this is really big. I'm concentrating the heat on the moil at the moment because the ends tend to be colder than the middle. The far end is exposed to the air, and so it's losing heat. The moil end has got a solid heat sink that's conducting heat, not very well, but it is conducting heat. And so kind of preferentially heating the moil, which is a giant chunk of glass. Applying a little bit of downward force here because I want my connection between the piece that I'm making and my puller moil. I want it to be really solid, so that when I go to pull this guy, I can pull with as close to 0 knuckle as I can get. So I'll just show a hot shot of what I'm talking about. So the center is starting to close up. I don't know. I may switch to one size smaller dies or not. I'm using the fixed dies as opposed to the iris dies because the fixed dies squeeze without distortion, and I want this pattern to be all compressed toward the center. The iris dies slide as they move. That's how the geometry works. It's an unavoidable consequence of the geometry. And I don't want sliding going on here because the pattern was designed to be squeezed strictly radially. So I may or may not want to go down a size in the dies. I may go ahead and do that. And like I said before, these dies have just been touching hot glass. Better not touch them with a finger. Get out the insulated glove. Just in general, working in this shop, I gotta constantly remind myself everything could be hot. Always approach carefully from a distance, feel the radiant heat. And of course that's what they say about glass. If it doesn't burn you, it cuts you. So I'm going down to 1 1/8 here, squeezing dies. It's looking really good, it's looking really smooth, it's looking really uniform. I see very little, if any, signs of overheat degradation and boiling, bubbling, blistering, and all the other kinds of things that I try so hard to avoid.